by talking about the relationship between angles. So it kind of ties into what we did last time, but with an additional new vocabulary word and some new vocabulary ideas. So the first rule, first vocabulary or main idea is actually something we went over last time called an angle bisector. Remember, your spidey senses should start tingling with the word bisector. It means cut in half. So we straight up defined this on our notes the other day, but an angle bisector is a ray that divides an angle into two angles that are congruent. And remember again that congruent means that they have the same measure. So bisects means they're equal because they're cut in half. Our next vocabulary word of the day is complementary angles. This should maybe be something from 8th grade that we remember. Does anyone remember what complementary angles are?
Lines that cross?
Not lines that cross. That's a good idea. That we will eventually get to lines that cross, actually today.
Look at the picture right beside it.
Yeah, if we have this picture right here, what do you notice about these if I'm telling you these are complementary? What do they total up to be? This with this little, I don't want to say the kind of angle it is, but this right here. What kind of angle is that? The big one. A right angle. How many degrees is a right angle? 90. So complementary angles are another word for angles whose measures total to 90 degrees. So underneath complementary, I want you to write a big 90 degrees because that's going to be the thing that you think about. They create 90-degree sums. They're called complements of each other. Okay, if complementary means 90 degrees, what is another really important angle measurement that we could call supplementary? If we look at this image right here, what do those two add up to be? If it makes a flat line or a straight angle, how many degrees is that? 180, very good. So what we're going to say is that for supplementary angles, two positive angles whose measures have a sum of 180 degrees. So underneath supplementary, write a big 180. Those are the two of the three huge concepts for today, that complementary angles make 90 degrees and supplementary angles sum to 180 degrees. Now, one thing I want to point out to you about complementary and supplementary angles is both of these examples here that you can see on the screen are, these two are complementary, these two are supplementary. This one is really obvious because we see the right angle. This one is really obvious because we see the straight angle. How come these two are also complementary and supplementary? They're not touching.
Together. Like,
what do you mean together?
Like the angles together equal up to like the top part, 70 and 20.
Yeah, exactly. We said the sum has to be 90. We didn't say they had to be touching. That's something different. But if we added these two together, 70 plus 20, isn't 70 plus 20 90? So those are complementary, even though they're not touching. Isn't 115 plus 65 180? Yes, it is. Which means those are supplementary. So again, complementary and supplementary, we're just talking about the sum, not necessarily that they're touching. But to talk about two things that are touching, we're going to call those adjacent angles. Have y'all ever heard this word adjacent before? Adjacent means that they are touching, or we're going to say glued together. So adjacent angles are the ones that have to be glued together. They share a ray. So two angles that share a common side and a common vertex, but have different common interior, or have no common interior points. So complementary and supplementary, like we kind of saw above, they can be adjacent, but they do not have to be. They can be non-adjacent, which means not glued together. Does that make sense? So these two angles here, though they're not complementary or supplementary, are adjacent because they're smushed together. This is the images we were using last time. They're all adjacent angles. Our next vocabulary word is called a linear pair. What do you see at the beginning of the word linear pair? Line. They kind of like make a line. And if they kind of like make a line, then they have to be equal to 180 degrees. But these are specifically ones that are glued together. So our definition here is two adjacent angles whose non-common sides are opposite rays. The angles in a linear pair are supplementary angles. So they create a line, their opposite rays create a line, and they're supplementary. So this is indicating that these have to be glued together because they're adjacent angles. So let's go back over things we've seen so far. Okay, complementary angles are worth how many degrees? 90. Supplementary angles are worth how many degrees? 180. Adjacent angles means that what? They are glued together, and linear pairs, because it says line at the beginning, are equal to what degree? 180. And they have to be touching. Those have to be adjacent. So those four words kind of go together. And then we have another idea here that's called vertical angles. Now, I think we went over this one in middle school, but I could be wrong. Vertical angles are angles that are on opposite sides of two intersecting lines, like Jordan wanted to say earlier. They share a common vertex but have different sides. So if we look at this image, and mine is color-coded, I recommend getting 2 highlighters and color coding like mine, that we have in this like cross, we have A and C across from each other. Agree? And then D and B are like across from each other, right? A and C are vertical angles. D and B are vertical angles. So they're like across the cross section from each other. Now what's nice, and the relationship between vertical angles, is that vertical angles are the same, which means they are congruent. So here with vertical angles, we're going to put the symbol for congruent. Remember, it's equal sign with the tilde on top of it, the squiggly line. Vertical angles are congruent, which means they have to have the same angle measurement. This allows us to have more relationships between different angles if we know about complementary, supplementary, and vertical angles. Okay, let's see if we can answer some questions using this vocabulary. The first thing we want to do is figure out which 2 angles are complementary. What does complementary mean again? They assemble to 90. They sum to 90. So if we look at our image here, which 2 angles would I be able to add together to make 90 degrees? The 53 and 37. But remember, we're going to name them specifically by their letters. So let's practice naming again. What would the blue angle be called? Angle RST. Very good. And then the green angle would be called angle CAB or BAC, as long as A is in the middle. Those are complementary angles because, and this is how we're going to answer these because angle RST plus angle CAB is equal to 90 degrees. That's what complementary means. It means that they sum to 90 degrees. Okay, the next one says supplementary. What do we know about the word supplementary? What do they have to add to be? 180. So let's look at our image again. Which of those 2 angles would add together to make 180? 127 and 53. Okay, so let's name it properly. If we name those 2, what's the name of the purple angle? CAD. And what's the name of the blue angle? We already named it, RST. So we're going to say they're supplementary because. And the reason that they're supplementary is because if we take their sum, angle CAD plus angle RST, it's exactly equal to how many degrees? 180. That's how you tell me why. That's the definition of supplementary. Okay, the third part says blank and blank are adjacent angles. What did that word adjacent angles mean? Glued together. So which of these 2 are glued together? Color. Let's just use colors. Based on my color scheme, which 2 are glued together? Purple and green. So we're going to name those appropriately. Purple one we called angle CAD. Green one we called angle CAB. And to tell me why they are adjacent, we're going to say they are adjacent because they share the ray called AC as a common side. Here's what I mean by that. We saw they were glued together, but this ray from A to C is where it's where they're glued together, yeah? So we say that they share this ray AC as a common side. That's why they're glued together. That's why they're adjacent angles. Are we feeling okay about this vocabulary? So these are the kind of questions you might see in this unit here. We're going to use this whole figure, a lot of things happening over there, to answer these questions. The first thing says, identify the linear pair that include angle 1. So we're going to identify 2 linear pairs that include angle 1. We just said that linear pairs create a line. They equal 180. So if I highlight, I'll do this one in blue. If I highlight angle 1, what other 2 angles form a line with angle 1? So we would have angle 1 and which one? What's another thing that makes a line with it? Okay, I feel like I'm asking this question in a weird way. Here's what I'm really asking. Isn't this a line? What other angle was included when I made that line? 2. So the other angle is angle 2. Okay, we can find another linear pair with angle 1 if I color it like this. So we have angle 1 and like this. Isn't that a straight line? So what other angle is also a linear pair? Angle 4. So they're the ones that create the straight lines with 1. Linear means line. So with 1, we have this straight line with 2, and we have this straight line with 4, which means those are also supplementary and adjacent. Okay, our next one, in the entire image, we're going to list 5 pairs of vertical angles. What did vertical angles mean again? Congruent. It also, in an image, means that they are across from each other and reflections of each other. So they should be the exact same shape. So if I was looking at angle 1 again, what angle is the exact same shape across from or vertical from angle 1? 3. Okay, that's 1 pair of vertical angles. Let me get you one to start with. If I want to start with angle 2, what is vertical to angle 2? 4. Okay, again, vertical angles are like flips across the line. 2 and 4 are across from each other, they're vertical. 1 and 3 are across from each other, they're vertical. What about with this part, with all these things happening? What is vertical to 10? 7. So we're going to write that pair down as well. So angle 10 and angle 7. What would be vertical to angle 9? And angle 6. Good. There's 1 left. What two numbered angles am I missing? Angle 5 and angle 8. Now my question for you, because this will be confusing in another drawing, is angle 9 vertical to both 5 and 6? It's actually no. Why is that no? Yeah, so if we look at the actual shape, and if I'm going to mark this out for a second, just so we look at these shapes right here. Are 5 and 6 the same size as 9? No, and of course, I'm assuming that this was drawn to scale. We can't always assume that, but for learning, we can use that idea. 5 and 6 are complementary, actually, and 9 is not worth 90 degrees as well. It's not a right angle. So those are not vertical angles. Okay, last question from this image. It says, are angle 6 and 7 a linear pair? Okay, first of all, we need to remember what linear pair means. We did this earlier. Linear pair means make a line. Do 6 and 7 make a straight line? Remember, straight line. Do 6 and 7 completely make a straight line? No, I'd have to turn right here, right? Boop. It makes an obtuse angle, but not a straight line. So we're going to say no. We're going to say no. Oh, highlighter. angle 6 and angle 7 do not form a straight line. If they had formed a straight line, we would say yes, because they're connected together and they made a linear pair. But they do not form a straight line. Okay, geometry loves asking questions like this. Well, in fact, our next unit is actually a lot of words. So our next thing is deciding if the statements are true or false. So part A says all adjacent angles are linear pairs. A lot of vocabulary. What did adjacent angles mean? Glued together. And linear pairs meant what? Linear pairs, what's at the front of the word linear? Line. They create a line they make 180. Okay, based on the picture that we just had in the other problem, especially looking at number 6 and 7, are 6 and 7 adjacent? Are they glued together? But did they make a linear pair? No, so this is false. Not every single one of the adjacent angles we have are going to create linear pairs. And the reason is we're just going to say see angle 6 and angle 7 above. Okay, because angle 6 and 7 are adjacent, but they did not make a straight line. So not all of them create linear pairs. Okay, part B says all linear pairs are adjacent. We flipped it. Linear pairs, we defined them to be equal to 180, but they had to make a straight line. For them to make a straight line, do they have to be glued together? That's a good question, right? Okay, so if we look at the image above, numbers 1 and 2 are linear pairs. We already answered that. Are they glued together? 1 and 2? Aren't they glued together? Yeah. We also said 1 and 4 are linear pairs. Are they glued together? Yeah. 2 and 3 are linear pairs. Are they glued together? Yeah. Every single linear pair has to be adjacent. This one is true. That is actually true by the definition of linear pair. Our definition for linear pair says that it is an adjacent angle that creates a straight line. So that's just true based on the definition. Okay, so we're going to use the idea that we have about all of these vertical angles, complementary angles, and supplementary angles to solve more problems like we've done before. Now again today, I'm going to use the box method to solve. If last time you were against the box method, that's fine, use inverse operations like normal, but I think a lot of us had light bulbs go off about the box method. So we're going to find the measurements of each angle listed. Okay, here's what we know. We have angle BAC and angle CAD. What kind of relationship do we have here? Do they make 180 degrees? Are they vertical? Do they make 90 degrees? 90 degrees. That's called complementary. They are complements of each other, which means we know that they sum to what degree? Complementary means they sum to? Give me a number. 90. Okay, great. So we can write this conjecture. We can say angle BAC plus angle CAD has to be equal to how many degrees? 90 degrees. That's what the definition of complementary is, that it's equal to 90. These are the steps we normally follow. We just wrote them in words so you can help yourself out later. Then we set up an equation. What is the measurement of the blue part, BAC? (10x plus 22). What's the measurement of the green part, CAD? 7x plus 34. That's all going to be equal to 90. Now, I said this last time, I'm going to stand by it. If your problem involves x's, and you need to solve, you can drop the degree symbol as long as you give it back to me at the end. So we're going to solve for x. We're going to use the box method in our notes. If you don't like it, you can choose a different method later. To solve for x, you draw your boxes, one on each side. Then we ask ourselves the following questions. How many terms up there in the last equation I wrote have x attached to them? 2. So I make 2 top boxes on this side. How many terms do not have x? 1, 2, 3. On all sides, there's 3. Okay, we drag and drop things where they go. 10x is going to drag and drop here to the first box. Do I need to change its sign? No. 22 is going to go all the way over here. Do I have to change its sign? Yes. How come that one had to change the sign? Cross the line, change the sign. Fabulous. Okay. 7x drops right here. No change because it didn't cross the center line. 34 all the way over here. Oh, spidey senses are tingling. We cross the line. We change the sign. 90 comes down right here. Did 90 have to change? No. Okay, quick review for box method. What do we do with all the numbers in the top? Add them. Very good. Add them even if they're negative. 10 plus 7 is 17x's. Negative 22 plus negative 34 plus 90. You give me that one in a calculator. Yes, 34. Fabulous. Okay, last step is to do what? Divide by the number in front of x, which is 17. So we divide by 17 on both sides. Bow, bow, bow. We get 2. Are we finished? Now, I'll tell you something right now. Your test that's next week. There's a test next week. There's a question with answer choices that asks you like this to find angle measurements. One of the answer choices is going to be the x. Don't pick it. That's not the question. It doesn't say solve for x. It says find the angle measurement. So make sure you know what the question is. So our question here is find the angle measurements. Well, okay, if the blue angle BAC, is equal to 10 times x plus 22, what can I put there in place of the x now? 2. In your calculator, what is 10 times 2 plus 22? 42, but if you just put 42, it's wrong. What do you put at the end? Degrees. Very good. We're measuring angles. It has to be in degrees. 42 as an answer to this question means you're telling me 42 radians? That's too big. It's different. To find CAD, you're going to plug, oh, I didn't switch colors. Angle CAD is equal to 7 times x plus 34, but again, you got 2 for x. 7 times 2 is 14. 14 plus 34 is 48 degrees. Plus 90 minus 42 is 48, so we know that they're complements of each other. Questions, comments, concerns about this? Is this part getting a little bit easier with the solving? I think it is. I can see everybody's a little bit less stressed. Let's try one more together, but I'm going to leave you be after we set it all up and see if we can solve and finish the problem. I will help you get the geometry out of the way. You'll take care of the algebra. Number 6 says angle EOF here and angle GOH are what type of angles? What is that called when they're like across from each other like that? Starts with a V. Flip your paper over. Vertical. Very good. Vertical angles. And what is the thing we know about vertical angles? It's the like equal sign with the squiggly on top. What does that mean? Congruent, which means the same. So we could say the conjecture we can draw is that angle EOF is exactly equal to angle HOG. Or GOH, I wrote it backwards, sorry. I'll follow the notes the way it's named them. GOH. Okay, so this time when we set up the equation, we're just going to make the whole two parts equal to each other instead of putting a plus sign in between them. So we would say 5x plus 36, which is the blue part from EOF, should be exactly equal to 11x plus 6. This is where I'm going to leave you because I want you to practice your algebras. That's it on geometry. Now we practice algebra, which means we set up our boxes and we solve. Cross the line, change the sign, divide at the end. I'm going to give you a couple minutes to work through this problem, and then we'll check together. Okay, I'm going to start walking through it. So if you're lost, look up at the board. And if you've got it, where did I put my pen down? Does anybody see my pen? Oh, never mind. I see it. Okay. If we were solving this one using the box method, I would draw my center line. Make sure you draw your center line. And I know I kind of, some 5 got a little big, but we can still manage because we need to know what crosses the center line and what doesn't. We already addressed that there are 2 top boxes for each. When I drag and drop, no change, yes change, yes change, no change. Are there questions on that step? Some of the problems I see with students here is that we forget to actually draw our arrows. I want you to draw the arrows. Show me where the terms are going. It'll help your brain change the right ones. When we add across the top, 5 plus negative 11 is negative 6. Negative 36 plus 6 is negative 30. I divide by exactly the number in front of x, including its sign. That's another number one place where students make mistakes. We drop the negative there. I have to divide by negative, which means x is equal to 5. Do I circle the answer choice that says 5? Please no, it doesn't say solve for x. This question says find angle measurements. And if you notice on yours, it's edited on mine. The letters are wrong in the part down there at the bottom. It still says BAC and CAD, my bad. Go ahead and change it to like mine. If we find these angle measurements, angle EOF is going to be equal to 5 times x plus 36. Well, we found that x was equal to 5. So in our calculators, we do 5 times 5 plus 36. What do you get? 61 degrees. Now, I don't have to do any extra work. I know that these are vertical angles, which means that they are equal. So without doing any other math. This other one is also 61 degrees. They are congruent. They're the same. If you plugged it in, you should get 61 degrees, but you don't have to. They're congruent. They're the same. Questions, comments, concerns about that?